Okay, this chapter has to do with inferences on percentages, proportions, and frequencies. And although there's a lot of different types, I'm just going to go through a few of them, or the most common ones that you'll see. First one you'll come across is something called a Fisher's test, and it's used with three specific kind of criteria: looking for statistical significance, having some kind of categorical data, meaning you either are, you aren't, yes, no, male, female, that kind of thing, in small sample sizes. And this is used to examine something called a 2 by 2 contingency table. And most people would respond to that, well, when you put it that way, it makes perfect sense. Well, what we mean is, for example, if we took a sample of teenagers and we divided them into male and female groups, we could have a category for male and female and a category for dieting and not dieting. So you could kind of think about on one side of this table having male and female, and across the top having dieting and not dieting. And our hypothesis would be that gender doesn't have anything to do with whether or not somebody diets. Or in other words, that the proportion of dieting individuals is higher among women than among men. And we want to test whether any preference or difference proportions could be detected. So we would end up with something that looks like this. As I said, we have gender, one being, let's see, in this case, we have male. Male is 1 and female is 2, and dieting is no. Or excuse me, not dieting is a 0, dieting is a 1. So we have this comparison. There's 11 men not dieting, 1 man dieting, 3 women not dieting, and 9 women dieting. So the question is does gender have anything to do with dieting? We want to know if there is a significant difference. So we go down through this and we come across all these different types of tests, and we're going to look at this one in particular called a Fisher's exact test. And we said we don't really know whether or not there's a difference, so we're going to look at this two-sided test as opposed to one-sided where we say there is a difference. Because this is less than 0.05, that means that gender does apparently have something to do with that. So the other thing I want you to look at is this deal called asymptotic significance. Asymptotic means approaching significance. It's a term that comes from mathematics. And sometimes the test that we're asking the computer to do is beyond the capabilities of the software. So it does this thing called an asymptotic significance. In essence, what it's saying is this is the best I can do with the information you gave me. If that is included, that's okay to use. If it gives you the exact significance, that's the preferred one to use. But we can also use asymptotic if that's all they'll give us. So that's an example of a Fisher's. The question was, knowing that 10 of these 24 teenagers are dieters, was a probability that these 10 would be so unevenly distributed between the girls and boys that is statistically significant. So you can see what would end up happening with that by going back and looking at this table. Another example of a test for percentages or proportions is something called a chi-square, a one-sample chi-square. And it is a different type of test that is used for categories and computes a chi-square statistic based on differences between these. So, for example, let's say that we have in our community, minorities make up 30% of the population in the community. And at a school, there are 20 minority faculty members among the 100 teachers in this school district. What we want to know in this case is, does the observed proportion, the 20% for the teachers, is that statistically different than what we'd expect it to be in terms of the 30%? In other words, we want to know, does our school differ significantly from what our community is? And this is an example of an issue that is very real for a lot of districts. For example, this local school district in Wichita Falls is having an issue with this. There are some people that feel like that there is a disproportion between the community and what is being seen in the school district. And this basically is just turning into a dichotomous test of either you're a minority or you're not, and is comparing one small sample to what we would hypothesize for a larger. And this is similar to something called a one sample t-test, which is, if you'll remember, the case where we have one group and we want to know if that group is different from a larger one. So we end up with something like this. As we said, we are observed minority, and this observed in this case means in the school district we have 80% that are 80 that are non-minority, 20 that are minority. What we expected to see, what we would have put in the computer, is 70 and 30. And the simple question is there a significant difference between this group and this group? Here's a case where we have asymptotic significance, and it tells us that because this is less than 0.05, that yes, there is a significant difference between our sample here and our population here. Another type of chi-square test is called an independent sample chi-square. Now let's just suppose we ask everybody the question. We could take this class or any other class, and we ask the question, would you marry your current spouse again if you had to do it all over? And we end up with several sets of responses, but they're limited responses. And basically what happens is we ask all the married men, would you marry your wife again if you had the chance, yes or no? And we ask the women of the same pair, would you marry your husband again, yes or no? And we end up with something like this. So in this case, 1 is male, 0 is female, 1 is yes, for yes I would marry that person again, 0 is no. So for example, here is a male who said yes I would marry my wife again. Here is a male who said no I would not. So this is where the raw data comes from. And we end up with something like this. 15 of the women said no, I would not marry him again if I was given the opportunity, while only 5 said yes. In this case, 13 of the men said yes, I would marry my wife again given the chance, and 7 said no. These 13 men are probably lucky that somebody married them all in the first place. But anyways, so our question was, is there a difference in the number of men and women who would say that they would marry their spouse again? So here's what we end up with, is on this part up here is the women. The count of said yes I'd marry the same one again. And 15 said that they'd marry somebody different, for a total of 20. Men said that they would marry their spouse again, while 7 didn't. So this is just a different way of representing the data. And we get a total down here at the bottom. It also gives you percentages of each of these groups, down here and down here, and what they expected to get. So we end up with this pattern. And what we see is, visually, it looks like there's quite a bit of difference between the number of men who said, yes, I would marry her again, and the number of women. But that's not enough. We want to know a statistic. So we go down through here, and we need to look at the statistics on this. And it appears that there is a significant difference between the men and women who said they'd marry their spouse again. I want to pause and come back to this in just a minute because I'm just about out of time.